Hello comrades. So today we are gonna do the part 3 in the series of Oscilloscopes 101. Up until now we have seen the display interface, the controls, the probes and the trigger menu. So today marks the third episode, which is about types of coupling. So it's basically a thing which means which part of the signal you want to see on the oscilloscope. So let's get started. Basically, coupling types, there are three of them, which is AC coupling, DC coupling and ground coupling. So AC stands for alternating current, DC stands for direct current, the usual stuff. And about ground coupling, it's basically to set your oscilloscope's reference ground. So basically, as the name suggests, it grounds your signal. So once you want to see, like if you get a 5 volt DC signal from power supply, you want to measure its output voltage or output ripple, then both of the ways you have to choose the appropriate mode of coupling so you get the expected result. So for measuring the output voltage of the power supply, we use generic DC coupling. So basically it connects the input of the oscilloscope directly to the measuring equipment, like the internal ADC circuitry and all. Basically what it does is, it does not block any component of the signal, basically not the AC component, not the DC component, and that works to like check the output voltage and every parameter and all. But if you want to see the ripple, like the AC noise only, which means the AC component only, then you have to choose that coupling mode appropriately. Yeah, so let's see the demonstration on the oscilloscope. So this is our setup scope. In here I have my power supply set to 5 volts. Its wires are coming through this and it's connected through this probe to this positive and the ground to ground. And right now if you see, there is no waveform or such things on oscilloscope. It's because the channels are turned off. So each oscilloscope might have some different settings, so you might need to tweak and research a bit about it, but mostly the functions and names would be similar. So for now it's generally a button, separate dedicated button on a scope. It would be named as some coupling type or something, but for this scope we have it on the settings menu. So once we turn on the channel option, you can see there's a line approximately from 2.5 divisions from the midline. So it's basically 2 volts per division. Yeah, if you can see this. Yeah, and it's 0, 2 volt, 4 volt and 5. So 4 and 5 and 6, like this it works. So right now if we see it, the mode, so mode is in, it says coupling type. Yes. So this is currently in DC coupling. So all of the component, like the DC component, offset and everything, and the AC ripple as well, is connected directly to the internal circuitry. It doesn't filter anything out. And if we see, even if we zoom in out a bit, we cannot see much of a ripple. It's basically just raw voltage and all. Yeah, this one. And if we go to the nominal, so just let's reset the 0 position. So this is the DC coupling, and now we'll shift to AC. Now this waveform might look pretty flat and all, but trust me, it's not flat. The earth and this waveform, they are not flat, believe me. So we'll shift to the jokes apart, we'll shift to the AC coupling. So in AC coupling we have the waveform, but it's nearly close to 0. So you will say, what's the point of this? Let me show you. As we zoom in, we get to see the noise and ripple by the oscilloscope, by the power supply. So this, it is peaking up around, let's see. So the spike is up to 400 millivolts or something. So that's basically the AC ripple coming out of the power supply. As you can see, it's a lot of noisy signal, and if we change the time per division scale, we get to know the proper ripple around it as well. If you zoom out, it's basically the high level noise showing lower time. Yeah, so if we can also zoom it in a bit more, so like proper see the, yeah, this is the noise I was talking about. In this we cannot see with the DC coupling mode because it cannot cancels out, like due to the heavy DC offset. The oscilloscope gets saturated, the internal circuitry and all. So this is what AC coupling means. And about the third option, let's go to the menu setting, and if we set it to ground, basically it connects the input to directly the ground. So if you zoom in even till like much 2 millivolts per division, so much resolution, it shows nothing, zero. Yeah, so that's basically the ground coupling. And if you set the coupling to AC, yeah, this is the very much zoomed in noise. So this is not changing, the noise is not changing, we are just changing the resolution and zoom of the signal. So this is what is being generated by this power supply. Yeah, that's why you need to get a proper power supply, because it might look outside like a good one, proper one and all, but once you get to the insides of the power supply, like what types of noise it's generating, or the yeah, this one ripple only, it depends upon the components types used inside the power supply. So you need to be careful about this. Yeah, so this was the topic of the video. It's types of coupling. Also in some oscilloscope you get the help menu as well. So if you click and let's for example search the channel menu, and this shows the coupling as well. Yeah, so what it says is DC means full state of the signal, AC means the AC part only, and ground means directly grounded. Yeah, and about this is a bandwidth limit as well. We can use this to eliminate the HF noise which we don't want in our signal. So like if you have some RF generating equipment nearby and it's radiating into the signals, we can eliminate that noise by a filter only. So yeah, these coupling types are basically oscilloscope filters, the same filters which you can use on social media and etc. Yeah, so it works in the electrical spectrum. So it uses like for the AC coupling, it puts a capacitor in series to the oscilloscope, yeah, signal. So basically capacitor doesn't allow DC to pass through, it only allows AC, because the reactance of the capacitor it change according to the frequency of the signal. So in DC it's completely high impedance, so the reactance is too much, and at AC as the frequency increases the reactance decreases, so it allows the signal to pass through. Yeah, so that was it for the video. Thanks for watching and have a good day. Thank you.